So the Open Weed Locator is something we developed back in 2019-ish up in Narrabri, in northern New South Wales at the University of Sydney. So I'm a researcher at the University of Copenhagen now, did my post-PhD at the University of Sydney, and I work on weed detection systems. In agricultural sciences, so my background, so I sort of came to this from not knowing anything about code, and I couldn't find anything to learn how to code that was relevant to agriculture. And things like weeders and weed seekers, they were costing like $20,000 just for a meter, which I thought was sort of wildly unfair because the hardware and all this cost maybe a few $100s. So then I was driven to do something that was low cost, DIY, as both educational as well as a practical tool. So now at the University of Copenhagen, looking at things like if weeds can adapt to being, avoid being detected by algorithms at all. So weeds, sort of ryegrass, can actually look more like wheat to avoid being detected, but that's a whole other story. But so currently weed control, as you'd probably all do, is probably blanket application. So you spray the whole crop, but even though weeds are only a very small percentage of that crop. It means heaps of waste, and of course you end up with maybe damage to the crop or inefficient use. So instead you can just spray the weeds. It's pretty logical, and you probably all really hoped for something that can do that. And that's what the Open Weed Locator is for. It was developed for green on brown scenarios, so where you detect anything green in a fallow field. But we're since working with Jake to make it into a green on green system. It's been made possible by some of the trends in technology. You might be familiar with, I guess, the hype around ChatGPT or those sort of large language models. But this is the cost of hardware over time per like how powerful it is. So cost per operation, so it's higher and to the right is better, basically. And you can see like maybe 5-6 years ago, things are quite expensive, quite inaccessible. But now if you look to sort of last year, you have things way up here that are much more powerful, much more affordable. So for people developing on this, all of a sudden you have really good access to low cost, very powerful tools that were not even possible even 5 years ago. And that is coupled with all the coding advantages you get from using things like ChatGPT or Claude, which are heavily used in the hour now. So I can add web pages, I can add new algorithms. While I'm working on hardware, it's sort of working next to me. So it's much easier to develop faster. And these are some of what they look like. This is the Raspberry Pi that's on the Open Weed Locator. You can see it a bit later. This is something they would use on, say, a John Deere tractor, same sort of device. And this is, again, another sort of hardware. So the way I like to summarize it, good things up, bad things down, which is sort of where they see technology going. So how does weed recognition work? And this is pretty critical. It requires a heap of data. Like you can have improvements in algorithms, you can have improvements in the hardware to run the algorithms, but if you don't have access to Manjimup red cabbage from Jake's farm, then it's not going to detect, at least well, the cabbage here or the broccoli or whatever else you're growing. So you really do need that data. Because the way it learns is you give it an input image. This is Palm amaranth, so amaranthus species in cotton out of Texas. You annotate it and you tell it where the weed is. And then behind that image are all these numbers and pixels. And so the algorithm sees what it is, makes a prediction, sees how it went wrong, and just does that millions and millions of times. And the more data you have, the hundreds of thousands of images you have, the better it will work. So this is the sort of data is everything. And you need hundreds of thousands of images. There are lots of, the reason algorithms are not such an issue is because of open source data, where lots of other people have developed really strong performing architectures. So once you have the data, you can then train these models, which exist already, and then you can use them on that hardware. So you really sort of need those three separate things. And most of that is open source, except the data and except the applications in agriculture. And I guess just for the open source side, it's just about sharing the recipe. So the way I usually describe it is about sort of biscuit recipes or sort of bakeries. You can sort of buy a pie or a Danish pastry, here in Australia, and you can also make that at home. But I'm probably going to go to Two Little Blackbirds and buy one of their pastries, or go to the local bakery, because they do it better, they do it probably cheaper, and they do it faster. So being open doesn't necessarily mean that someone's just going to steal everything. They'll probably do it anyway with AI these days. It just means it's more accessible to people like Jake and everyone like yourselves to work with it, as opposed to having to go through a very large company. So it's just open source. When you hear that, that's just recipe sharing. So on the data collection side, that's been one of our biggest tasks, I think, and that's, I think, your original data collection device there, right?
That is it,
yeah, I don't know if you want to get that out, but it's just mounting one of these cameras and going through the field and collecting data in whatever condition you're hoping to use it in.
That there is the original, what you see outside, this is what it started off as. So it's come a long way.
Yeah. And Jake, again, it's really cool because that was, I just sent Jake I think the camera, right, and I think it's the designs, and these guys just came up with that enclosure entirely themselves. Like, I wouldn't have been able to sort of come up with that sort of stuff. It's just nice having, again, being open with it and letting people develop with it. But I always tell myself the second best time to plant a tree is today, and I think that works with data collection. So you may not have the perfect setup, you may not have the perfect data, as we sort of found out. It's slightly changed between that and the system now, but we'd have nothing if we just waited until we had the perfect system. So if you really want to start, just do something like Jake's done. Might not be perfect, but it'll get you some of the way. But now for the open weed locator. So as I mentioned, it's DIY, low-cost system. It runs a Raspberry Pi. So you have, this is the computer just here, this is the camera, and this is the relay control board. This is a newer version, again, only 4 outputs, but we worked with Jake because they needed 16 outputs for the precision spraying in vegetables. Each output is just 2.5 centimeters, and so you can control much more fine diesel injector nozzles instead of these much wider, so 25-degree flat fan nozzles. And the biggest thing about it is the community. So if you had people build them in about 10, I don't know, different countries roughly, like Australia, Canada, Denmark, the US, Argentina, Mexico, I think China, India, all over basically. Because it's cheap, people can work with it as a student project, they can build it on their farm, you can sort of mount it to a bicycle. It's because it's open, because it's cheap, you can sort of start to innovate with it to suit your circumstance. Because I think agriculture is full of niches. I think having, again, that openness is really important. This is a grower in Mildura in the 7 hours west of Sydney, and he's doing it spot spraying around his farm. He built a 4-metre system. I think he's hoping to replace those older modules with the newer ones, but he built that all himself without contacting me until he'd finished. And this is one on an ATV in New Zealand doing spot spraying along the driveway. Again, he sort of built this, and we sort of talked to fix some of the problems, but he decided to indicate up here where the nozzles were turning on. He decided that was more important, so he also added that feature, which isn't part of the normal system. So the vegetable, so our data set that Jake collected, and then he collected about 3,000 images, sent them to me, we got them annotated. There's about 15,000 weeds and crop plants in there. The best is to collect exactly how you use it, but anything is better than nothing. And so this is the algorithm we built. You can go to that website and try it on your own data if you want to. I can show you that right now as well. So this is an image from Jake's red cabbage field that we collected. And then you can run over it and detect the weeds and the cabbage. So if we select the wild radish and clover that's been detected in this image, this is what we're trying to achieve. So there's 16 channels here, and the sprayer hopefully moves over this and just sprays the weeds. So you can see here it's detecting the wild radish, just turns on there, ignores the cabbage, and then just sprays the clover just there. Alternatively, you can also just spray the cabbage itself and not the wild radish or the clover, and you can apply things like fungicides or I guess other plant protection. And again, you just spray the red cabbage up there. That's the idea of what we're trying to build outside. And you can try your own photos with that if you want. This is a website anyone can go to. So if you want to try your own images, just go to that.
So far we've collected 3,000 images, and it's cost us about $1,000 to annotate them. For a good model, you need about 50,000 images of each crop or each species. So 50,000 red cabbage, hey Guy? Yeah, roughly. 50,000 red cabbage, 50,000 images of double G, 50,000 of a ryegrass, so on. So I think moving forward, like, open source technology is the way to go. Like, for a small family farm like we are, 60 acres of vegetables, like, we can't afford a $250,000 machine and $10, $20, $100,000 a year subscription fee to go with the machine. So hopefully, yeah, going forward we can get an open source weed library, so there'd be no subscription fee, and open source cameras and machines like this so that you can upload those libraries into the machine and go out and spray, I suppose, spot spray your crops at a price that's affordable for family farms, and not just like, not having this technology targeted at those corporates or those huge farms. So
part of this project as well was developing the green on green capability to run on the Pi, so detect weeds amongst Jake's cabbages. And so there's the green detection only, which is what we can demo here, what you can spray around the, I guess when you don't have a crop.
Which would be your bare fallow sprays.
Yeah, and that's probably the easiest one to get started. You don't need data for that, it just detects green. Also probably the most prone to light changes. The next one is a hybrid mode, so you can detect the cabbage and you subtract the cabbage out of the image and then spray everything else that's green. And that runs a bit faster than the other model and a bit better at detecting, I guess, weeds. And the final one is AI only, where you just run the model itself and then you can spray just double Gs, or you can spray just grass, or you can spray all the weeds, not the crop, or you can spray just the crop. You sort of decide on what you want to do. But it's not as good as detecting the weeds because you have to make the images quite small. And maybe make the images small, you miss more weeds. So I think we're still figuring out what the best option is, probably different for different circumstances.
And we're working on a new computer that can process. I think the processing power at the minute and the cameras we've got, I can't process the AI images at a speed that can keep up the tractor.
So that's the newer version of it. So we're hoping this is only 4 outputs, but in the next sort of few months we'll hope to start selling kits of these. Again, still open, but you can just buy a kit as opposed to doing it yourself, and then convert this into 16 channels. So you'll see the big black boxes outside, they're the equivalent of this. This has more power, it's got GPS inbuilt, it's got 4G and everything. So it'll be much better than the ones out there.
I think the first step would be you go onto Guy's website.
Go to openweedlocator.org. We have a community platform as well, so there's lots of farmers talking about each of their applications. You could always pose a question there if you're interested. There's also all the documentation, so the quick start. Everything you can see on Jake's tractor, the controller, the owls, that's about a 3-line install once you have the hardware set up.
And thanks to our host, 3 Ryans.
Thank you.